Hello again, students. Today we are going to just do one example of a linear programming problem. So if you don't know what I mean by linear program, you need to click out of this video and go back to the last one, which was over an introduction to linear programming, because this video is going to tie it all together. All right, so in this example, it says a company makes two types of biscuits, jumbo and regular. The oven can cook at most 300 biscuits per day. Each jumbo biscuit requires 2 ounces of flour. Each regular biscuit requires 1 ounce of flour, and 500 ounces of flour is available. It costs 12 cents to make a jumbo biscuit, and it costs 5 cents to make a regular biscuit. Jumbo biscuits sell for 20 cents each, and a regular biscuit sells for 18 cents. How many of each size biscuit should be made to maximize profit? All right, so a lot of words there. So it's up to you to read through it, okay, and then just dissect it. All right, so first thing that you should do is figure out what are you trying to find? All right, so that last question, that last sentence has the question. It says, how many of each size biscuit should be made to maximize profit? All right, so what the company has in their control is the number of each type of biscuit that they make each day. All right, so we're going to define our variables. Okay. And so let's go ahead and let X represent the number of jumbo biscuits. And we'll let Y represent the number of regular biscuits. All right, so then before I do anything else, because I just defined my variables, and I know that I'm going to have a graph for this, what I'm going to do is I'm going to label my axes. So along the x-axis, I let X represent the number of jumbo, and along the y-axis, that's representing the number of regular. All right. So that's part of it. That's what they have in their control. So those are the variables, how many of each they're going to make each day. But then that sentence also says, should be made to maximize profit. All right, so that's the goal there. And that's a very important business goal, is that you need to figure out, okay, how am I going to be most successful? All right, and a lot of the times business is driven by money, and that's going to be your profit. That's what you're looking for, is how much money that you're going to be bringing in. All right, so if you don't know this, profit, okay, profit is equal to your selling price minus your cost. Okay, so if your cost is more than what you're selling and you're making off of an item, it means that you're not going to be making a profit. You're going into the deficit. All right, but if your selling price is higher than your cost to make it, whatever is left over, that's the profit. All right, so off to the side, I'm going to put this down in case you don't know this definition. Profit. That's going to be selling minus cost. Again, that equals your profit. All right, so we're dealing with money. So now we're going to go back through and we're going to pick out the numbers that deal with money. So I see 12 cents, I see 5 cents, I see 20 cents, I see 18 cents. All right, so now I need to tie those together. 12 cents to make jumbo, 5 cents to make regular. All right, so this number, 12 cents, is associated with jumbo. This number, 5 cents, is associated with regular. Jumbo, so once again talking about jumbo biscuits, so there's the word jumbo, sell for 20 cents each, and regular. All right, so that means that these numbers are going to go together, and these numbers are going to go together, because both of these numbers relate to jumbo, and both of these numbers relate to regular biscuits. Okay, remember, profit is your selling minus your cost. All right, so down here where we work with the objective function, all right, so for the jumbo biscuit, okay, up above, it says that the selling price is 20 cents and the cost of making a jumbo biscuit is 12 cents. All right, so this is going to give us the profit. All right, so 20 minus 12, that's going to give us 8 cents per jumbo biscuit. So if there's only one, it'd be 8 cents. If there's two, it'd be 16 cents, and so on. Remember, X represents the number of jumbo biscuits. All right, for the regular biscuits, okay, up above, it told us that a regular biscuit sells for 18 cents and that it costs 5 cents to make it. So 18 cents minus 5 cents would be 13 cents. And again, that's per regular biscuit that's made. This company makes both, so they're going to make a profit off of this, hopefully, and off of this, so we're going to be adding those together. And this right here, this expression, this 0.08x plus 0.13y, that's the objective function. All right, that's how they are going to get a profit. All right, so then it's going to be up to us to figure out how many of each type of biscuit is going to be needed in order to maximize that profit. All right, so rather than just plugging in random numbers, okay, we're going to come up with what are those restrictions? What are those constraints? All right, so that's what we're going to do next, is coming up with the constraints. So 2 of them, almost always, are a no-brainer. Can't have a negative number of jumbo biscuits, nor can you have a negative number of regular biscuits. So this right here, x is greater than or equal to 0, y is greater than or equal to 0. This is saying that you're only going to be working in the first quadrant. All right, so graphing this over here, I'm only going to use the first quadrant. So I'm going to do the best that I can, and you'll have to do the same. And make it so you're only looking at the first quadrant. So graph that y is greater than or equal to 0 and x is greater than or equal to 0 right here. Okay, other constraints. Okay, so one thing you can do is once you've used the numbers, so all of these dollar signs, okay, that went with cost and selling prices, we already used those. So now what we can go back and do is pick out the other numbers and figure out what other kinds of constraints that we have. All right, so this one says the oven can cook at most 300 biscuits per day. All right, so in that oven, they're going to cook jumbo biscuits and, so plus, regular biscuits. And the oven can cook at most 300. So you could cook less than 300, or you could cook equal to 300 if it's at most. All right, so here's a constraint. We still have a few more numbers. It says each jumbo biscuit requires 2 ounces of flour. So each jumbo requires 2 ounces of flour. So I'll put down a 2. Jumbo biscuits, remember, are X. So if you only have 1 jumbo, it's 2 ounces of flour. If you have 2, it's 4. And if you have 3, it's 6, and so on. You're multiplying. But then you also require flour. So plus, regular biscuits require 1 ounce of flour. So you can put a coefficient of 1 if you want to. But then regular biscuits, that's the variable y. So again, you can put a 1 out here in front if you want to, but you're adding the fact that each regular biscuit that you have will require 1 ounce of flour. And 500 ounces of flour is available. All right, so if you only have 500, it means that you could use less than 500, or you could use all of it and make it equal to. All right, so now what we need to do is these 2 constraints need to be graphed, and because we have both variables, it means that these are going to be slanted lines. It's going to be up to you how you want to graph them. Okay, on this one, it's pretty straightforward. I think what I'm going to do is I'm just going to solve for y. So I'm going to move x over. I'm going to move x over by subtracting x because you have to undo it, and right now it's positive. So it's going to give me positive y is less than or equal to negative x, and then that was positive, so plus 300. So this is going to give me my slope. The number in front of x is negative 1, so I'll write that as a fraction. And then the b, the y-intercept, is at positive 300. For my other constraint, I could do the same thing. I could have y and solve for y by moving the 2x over. The other thing I could do is solve for intercepts. All right, so just let me do a quick refresher for you with intercepts. If you want to find the x-intercept, that means that your y value is 0. So you're going to replace y with 0, and you're going to solve what's left. So that would give you that 2x is less than or equal to 500. That would give you that x is less than or equal to 250. So the x-intercept would be at 250. The y-intercept, that's when your x value is 0. So if you plug in x for 0, or 0 for x right here, 0 times 2 is 0, plus y is less than or equal to 500, which means that the y-intercept is at 500. All right, so something we should notice here is we're talking about plotting points 250, 0, 0, 500. This one would be 0, 300. Okay, we're getting into pretty large numbers there. So that means that we're not going to be able to count by ones. 1, 2, 3, 4. We're going to easily run out of room. There's no way we're going to make it to 500. So what we're going to need to do is change our scale. And I said in the last video, you can change your scale differently. Your x-axis and your y-axis can be different scales. However, it's probably going to be best if you make them stay the same, because over here, I'm going to be graphing using slope, which means that in order to graph using slope, the scales need to be the same. If you're just plotting points, they don't need to be. All right, but we're going to make this graph look the best that we can. So we're going to change the scale and make it the same for both. All right, so if we're getting up to 500, pick a number, okay, to go by that goes into 500. Same with 250, same with 300. So what are they all divisible by? What would be something that's nice that would be able to get us there? And that's going to be 50. All right, so I'm going to go ahead and label my x-axis and my y-axis. And I will try to pause this video so you don't have to watch me do it all. All right, so now my x-axis scale goes by 50s. So notice how I'm consistent. Going over one line means 50, then 100, then 150, and so on. And I just realized I made a mistake on my y-axis, so I'm going to need to go back and change that. All right, so pay attention as you're going. It's easy to make mistakes. I just did. All right, so now I made it so then my y-axis is also going by 50s. So one line up is 50, after that it's 100, 150, and so on. And I went all the way up to 500. All right, so now what I'm doing is I'm going to graph this constraint that said the oven max. All right, so x plus y, the number of biscuits being made, had to be less than or equal to 300. All right, so the y-intercept was at 300, so I need to plot a point up at 300. And the slope is -1/1. So down 1 to the right 1, down 1 to the right 1, and I'll do so until I run out of room to plot any more points. All right, and then the best that you can, and that's all you can do with these, is try to be the best that you can with it. All right, I'm going to connect all of those with a solid line because it was or equal to, which means that these points right now would be included in the solution. All right, for the other line, I could have graphed using the slope. Moving that 2x over would have been a slope of -2/1. However, I said I was doing I can kind of do a combination of the two. The y-intercept was at 500. All right, so on the y-axis, I'm going to plot a point at 500. And again, that slope, moving that 2x over, would be -2/1. So down 2 to the right 1, 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 and that's good news. It puts me on the x-axis at 250, which is what I had said my x-intercept was before. All right, so now, once again, I'm going to connect these with a solid line because, again, it was or equal to. All right, so now comes kind of a tricky part, and the more precise you are with drawing your inequalities, so mine are a little shaky because I'm doing it on the computer. All right, we need to find that feasible region. So we need to figure out where all of our shading is going to overlap. So we have this area down here that's below both of our lines. We have this small triangular region right here. We have this unbounded region up here. And then we have this triangular region right up here. All right, so we need to figure out where are these going to be. All right, so you can use test points, okay, or, okay, you can also do something. Let me get rid of this line right here. Another option is you can look just to see what your inequality symbol is. All right, so the reason why this one's a little bit tricky to use the inequality symbol is if you ever multiply or divide by that negative, do not forget to flip your inequality around. All right, we didn't multiply or divide by a negative, so this is saying that y values are less than this boundary line. So that was this boundary line. We're looking for y values that are less than, so we're talking about below. Again, if that doesn't make sense, use the test point, 0, 0. All right, so if I plug in 0, 0, that's going to give me 0 plus 0 is less than or equal to 300. 0 is less than or equal to 300. That's true. All right, so here's 0, 0. I would be shading down here below the red line. So right now it would be this area right here, this small triangular region, as well as this region right here. All right, now for the other inequality, if I move that 2x over, I'd still have y is less than or equal to, so same thing. Here's my boundary line. I'm talking about anything that's below it. Again, I could use a test point. 2 times 0 is 0, plus 0 is less than or equal to 500. Once again, that's true. All right, so 0, 0, that's where I'm going to be shading. So that means it's going to go everything below red right here, and then it's going to switch to everything below green. And then now we just need to butt it up against the x and the y-axis. All right, so all of this shading that overlaps right here, this is called the feasible region. Pick any point and you're going to make a true statement. It would satisfy your constraints. All right, so all of these would be possibilities. Now, we don't want just any of these possibilities. We want the best one. All right, so a mathematician long ago figured out that the best solution always lies on one of the corner points. All right, so this feasible region is bounded by right here, this portion of the y-axis. It's bounded by this portion of the x-axis all the way up to this green point, okay? And then here, where the green and the red intersected, and then back up to the y-intercept of that oven inequality. All right, so we have 1, 2, 3, 4 sides. So we're going to have 4 corner points. 1, 2, 3, 4. Yes. All right, so let's do this corner point first. Let's go ahead and do 0, 0. Okay. Then we have this corner point right here, which is on the x-axis at 250, 0. Then we have the point of intersection, which is why it's always important to plot as many points on your line before you just connect them. This point of intersection, where I placed the dot for both, was at 200, 100. And then the last point of intersection, this was only where one of the inequalities was. This was at the y-intercept for the oven, which was at 0, 300. All right, so don't forget that in an ordered pair, you always have x, y. So what we're going to do is we're going to plug in these values into the objective function. And then we're going to evaluate. So this is going to be 0.08. We're plugging in 0 for our x, plus 0.13. We're plugging in 0 for our y, which obviously is just going to give us 0. If you don't make any biscuits, you're not going to make any money. All right, the next one, we're going to substitute in 250 for x, and then 0.13 times 0. So you can use a calculator. 0.08 times 250 is going to give you 20. For the next one, we're going to take 0.08 times 200 plus 0.13 times 100, and 0.08 times 200 plus 0.13 times 100 is going to give us 29. And then the last one, 0.08 times 0 plus 0.13 times 300 is going to give us 39. All right, so these are our values. Remember, our objective was to maximize profit. All right, so this is talking about our profit. So 0, 20, 29, and 39. So not very much. We don't really know the situation that's going on. Maybe, I don't know much about making biscuits or anything like this, but I can tell you that profit right now, we're talking about money. That's our units. We're talking about making a profit of no profit at all, $0, making a profit of $20, making a profit of 29, and making a profit of 39. What I can tell you about profit is you always want to maximize it. You'd want to make the most money for your business. So there's the largest number that we have. Even though it's not the largest number in the world, 39, it's still something. It's better than nothing. So maybe this company just started up. All right, so now you're going to interpret your answer. You're going to interpret your results. All right, so what we have here is we have under these constraints, because maybe they could get a bigger oven, okay, or maybe they can buy more ounces of flour, and then the problem would change. But under these given constraints, this company should make 0, okay, because we have a result of 39 when x is 0. So they should make 0. Remember, x stood for your jumbo biscuits. So they should make 0 jumbo biscuits. And y was 300, so which that means that they should make 300 regular biscuits in order to have a maximum profit of $39. All right, and that is it. All right, so what did we do again? Okay, hardest part, okay, is probably going to be reading through the problem and actually coming up with the math symbols, the math inequalities, what you actually need to do. Okay, this part right here is just graphing a system of inequalities, so that shouldn't be that difficult. All right, so read through the problem, figure out what can I change. Those are your variables. Those are what's in your power to change. Make sure it always represents a quantity. So I didn't just put jumbo biscuits, I put number of jumbo biscuits. For your graph, don't forget to label your axes. You'll also need to come up with a scale, but before you make your scale, you're going to need to come up with your constraints. Okay, your constraints. And then figure out how are you going to graph those constraints. Are you going to use slope-intercept forms, or are you going to use the y-intercept and the slope, or are you going to use the intercepts? It's probably a good idea to make sure that the scales match, especially if you're using slope, they have to. Okay, then you're going to figure out, okay, where do all of my constraints, where do they all overlap? That's called the feasible region. And then you're looking for the corner points of the feasible region. Those will go into the table, okay? And then you're going to be plugging those into the objective function. So you're also going to have to pull out from the words from the beginning, what's the object? What are you trying to do? What's the goal? So a lot of the times it's about maximizing profit or income and minimizing cost. Okay, those aren't the only ones, but that's a lot of the time the types of problems that we deal with linear programming. So then you're going to plug your corner points into your objective function, you're going to evaluate, and then you're going to pick either the highest number if you're trying to maximize or the lowest number if you're trying to minimize. And then whatever the ordered pair was, that tells you how many of each you should have. And that's what you need to then put into words as an interpretation of the entire problem that you just did. All right, and that is called linear programming.